let's take a look at the real easy kind first. Let's suppose you had an x to the sixth minus an 8x to the third plus a 15. All right, now I'm going to venture to a guess that many of you could factor this without doing a U substitution, okay? But if you learn it on this, then when I change this, instead of just having an x there, when I change that to a binomial, then you have to use the U substitution. All right, so we're going to do this as if you are not using the U substitution. All right, let's just say some of you are sharp enough that you could look at this and go, oh, if this is an x to the sixth, and this is an x to the third, I'm definitely in quadratic form because this exponent is half of that. And to get an x to the sixth, well, if I had an x to the third and an x to the third, when multiplying like bases, we add the exponents. So those two multiplied together would give me that x to the sixth. All right, and then if you started your factors of 15 and start guessing and checking, you'd get 1 and 15. Well, that's not going to work. And then you try 3 and 5. Oh, and then that's going to give me an 8. All right, so you're going to put a 5 in there, and you're going to put a 3 in there. Now, the only way to get 8 would be to add these two. I need them to be negative to get a negative 8. Okay, and then a negative times a negative does give me that positive 15. All right, so like I said, just that was simple. All right, you don't have to use a U substitution on that. However, I want you to use U substitution so that you get used to how this is going to work. Okay, now let's do a U sub on this same problem and do it because it's easy. Okay, so let's start out with the x to the sixth minus 8x to the third plus 15. All right, now I made reference a minute ago. This one is an x to the third. This one is an x to the sixth. 3 is half of 6. So this is in quadratic form. All right, later in this chapter, we're going to solve equations in quadratic form in this U substitution, or maybe in another chapter actually. But we will deal with equations in quadratic form that you need to solve. So first of all, you got to know when it is in quadratic form and when it's not. And it's because the 3 is half of the 6. All right, now when it's in this quadratic form, I can use a U substitution and I can take whatever this middle variable is with its exponent, and that's what my U is going to be. All right, every time, okay, because we want to have something squared to get this. All right, so we're going to let U equals x to the third. All right, now when I do that, this will become a trinomial in terms of U. This first one, I want it to be a U squared plus some number U plus another number. I want it to be in the standard trinomial with that first term being squared, the second term being just the plain variable, and the last term being a constant. All right, so it's going to be a U squared and then minus whatever that middle coefficient is, an 8U, and then a plus 15. All right, in terms of U, this is equivalent to that. Okay, now why? If U is an x to the third and I square it, power raised to a power means multiply, so that gives me an x to the sixth. So this right here gives me the x to the sixth, which is what I need. If I take this U and just simply replaced an x to the third, I would get this term. All right, and then the 15 is just the 15. So this form right here is always the same line every time. Okay. All right, now that we did that to demonstrate where that came from. All right, now this is in terms of U. It's a nice plain U squared. Okay, so we can go U and U. And again, it'd be the same two numbers over here. We would guess and check them. We'd get the 5 and 3. We get the minus and the minus. All right, everything's good. It's all factored. All right, now this answer is in terms of U, but my original equation, polynomial, there's not really an equation, is in terms of X. I need my answer in terms of X. So I need to replace U equals x to the third. All right, so then I'm going to take this U and I'm going to take that U and I'm going to replace it with x to the third. So x to the third minus 3. All right, and then x to the third minus 5. And yes, we get the exact same answer. And I know what you're thinking. You're sitting there going, why would I want to do this when I can just do this? All right, and it's because this is an easy problem because the bases are single variables. This is just a plain x, and this is just a plain x. All right. So when they're just plain x's of the bases, it is easy to do it without the U-substitution. However, you force yourself to learn the U-substitution on the easy ones. And when I make this a binomial, all right, then you'll already have this down pat. Okay. So now let's real quickly here move this up to a harder one that's got a binomial in the bottom. Okay. So let's say we have an x plus a 1, and let's just keep it to the second power. Let's not even make it to the fourth or to the fifth or anything like that. Let's just keep it to the second power. All right, plus a 6 times an x plus a 1, and then plus a 5. All right, now my bases are now binomials. Okay, the bases, this whole thing is the base being raised to the second power. And then this is a base being raised to the imaginary 1 power. All right, I am in quadratic form because this exponent is 2, this exponent is 1, so it's half, so I'm in quadratic form. All right, so I want to start with letting my u be whatever the variable and exponent is on that first middle, or not first term, middle term. So I'm going to let my u equal an x plus a 1, and I don't need to write it to the first power. Okay, and then now my second line here is always going to be a u squared plus whatever this coefficient is, u, plus this constant. So I'll have a u squared plus a 6u plus a 5. All right, now I've got a nice little quadratic there, leading coefficient of 1. It's in a single variable, so I can guess and check this. I've got a u and a u. All right, everything is all pluses. 5 times 1. I don't have any other choices here, so plus and plus. That gets my 5. That gets my 6 in the middle. All right, so again, that factored pretty easy. Now, this is in terms of u, but my original equation was in terms of x. I need my answer in terms of x. So I'm going to replace my u with an x plus a 1. All right, so this is going to get replaced, and this is going to get replaced. Okay, so I'm going to put in for that u, x plus 1. And then this plus 1 has to stay there. All right, this u gets replaced with this x plus 1. And then I got to keep the plus 5. All right, which then makes this what? An x plus a 2, and this one an x plus a 6. Okay, so that's kind of why we need to learn the U-substitution. Do it on the easier problems, get down pat what you're doing. Then when you get a harder one with a binomial in there, then you're going to be able to apply that process of that U-substitution. And like I said, this is not the only place. They're just introducing this U-substitution in this chapter because we're factoring. Later on, in a couple chapters or later on in the semester, whenever it is, we will be solving equations in quadratic form, and we will have to use this U-substitution to do it. All right, so the sooner you learn to do it, the better off we're going to be. All right, now let's go ahead